This is problem 5.5. Okay, the question states that find the natural frequencies of the system shown in figure 5.24 with m1 equals to m, m2 equals to 2m, k1 equals to k, and k2 equals to 2k. Determine the natural frequencies and mode shapes of the system when k equals to 1000 and m equals to 20 kg. So, given that m1 equals to m and m equals to 20, alright, so we get this. And then m2 equals to 2m, so meaning 2 times 20, you get 40. Alright, and k1 equals to k, which is 1000, and k2 equals to 2k, meaning 2 times 1000, you get 2000. Alright, so now what we have to do is, first of all, is to find the equation of motion. So for this question over here, as you can see in the diagram given, okay, it is actually very basic, meaning it's only the system is translational. Okay, it's undergoing translational motion only. Okay, so if in this kind of case, okay, as you can see in this problem 5.5, if the system is only translational or only rotational, okay, meaning it only have x or only have theta, so the way of extracting the EOM, the equation of motion, is, okay, now let's take a look at m1 over here. Alright, so m1 is moving, so you can put it over here as m1 x1, right? m1 is undergoing motion in x1 direction, so m1 x1 double dot. Okay, that's the way you put it. Next, this, since you have two bodies here, m1 and m2, meaning you have two equation of motion, so plus with, okay, m1 is attached to k1 and also k2. Right, since m1 is attached to k1 and also k2, so you add with k1 and also you add with k2 at x1. Alright, now since m1 is also attached to k2, where k2 is not only attached to m1, k2 is also attached to m2. So k2 is attached, spring number 2 attached to two bodies, body m1 and a body m2. So since m2 is not related to m1, so you minus with k2 x2 equals to 0. Okay, do the same thing for the second equation of motion for m2. Now m2 is undergoing to x2 direction, right? So m2 x2 double dot. Okay, m2 is attached to k2, so since it is attached to k2, we plus with k2 x2. Okay, but still you have to remember that k2 is not only attached to m2, k2 also attached to m1, so m1 is not related to m2, so for this equation here, we minus with k2 x1, right, equals to 0. So if the spring is attached, for example k1 is only attached to m1, so k1 plus with m1 x1 double dot. Okay, since k2 is attached to two bodies with m1, so at first we plus k2 x1 and then we minus k2 that is attached to m2, so k2 minus with k2 x2 with the displacement of x2. Okay, so you do the since you have two bodies, two equation of motion, and then we rearrange. Alright, we rearrange this, okay, because we want to change it into a matrix after that. Okay, so matrix in terms of x1 and also x, x2, so rearrange so that it will be easier for you guys to see. So now I'm going to rearrange it into x1 first, only then x2. So for the first equation, nothing that we can change. Okay, just leave it that way. Next. Plus with m2 x2 double dot plus with k2x x2. Okay, now since we've already rearranged, now we are going to insert it into a matrix. You're gonna make it into a matrix. So now how are we going to do this in the matrix form? So whatever's that is x1, alright, whatever that is x1, I'm gonna put it on the left side. Okay, this is x1 over here. Okay, so put it in a matrix. Okay, as I put it over here, if you have anything with double dot, straight away change it into negative omega squared. Okay, negative omega squared. When you put it in a matrix, there's actually a legit long derivation to explain why x double dot equals to negative omega squared. But you can take a look in your textbooks. I'm just gonna make it easier for you guys. All right, so just do this steps to all kind of questions that uses this. If the question asks you to find natural frequencies and mode shapes, just do this. All right, so m1 negative m1 omega square, all right, plus with k1 plus k2, that is for x1 part. Okay, now also on the bottom part you have for x1 negative k2. Okay, this part over here is for x1. Okay, now this side is for x2. Extract the x2 from here. On the top part is negative k2, and on the bottom part is m2 x double dot, so it's gonna be negative m2 omega square, because x dot equals to negative omega square, and then plus with k2. All right, plus with k2. All right, and then x1 x2, because I put x1 first, right, only then x2 equals to 0. Okay, I just change from a normal equation, right, simultaneous equation, into matrix form. So now how are we going to solve it from here is that, okay, from here I'm gonna change it into a determinant form, okay, which we call it as the frequency equation form. So just copy back everything that you see over here. Okay, and then put it this way. Okay, if I'm not mistaken, you guys already learned about determinant, on how to solve determinant in your linear equation class. All right. Okay, so you do it that way, equals to 0. And next, before you further solve this, since we don't want to make it very complicated, you have to derive everything just using this alphabets, omega, m, k, and all. So substitute the values first. Okay, we already know the values, right? m1 equals 20 kg, m2 equals to 40 kg, k1 equals to 1000, and k2 equals to 2000. So substitute all the values. You get the values to be, all right, negative m1 now is equals to negative 20 omega square, plus with k1, which is 1000, and plus with k2, 2000, you get over here 3000. Negative K2 is negative 2000. Alright, now over here also negative K2, so negative 2000. On the bottom part of the right side is negative M2 omega square. Alright, so negative M2 is negative 40 omega square, plus with K2, which plus with 2000. Okay, and everything equals to 0. Okay, now since we've already done that, we've already done the frequency equation. Now we are going to solve the frequency equation using determinant. Alright, so using determinant, as you can see, I've already laid out the formula for you. For example, you have determinant of 2 by 2 equals to 0. So how are you going to solve this? Okay, cross multiply, so you get AD minus with CB equals to 0. That's how you do it. So for this part over here, how are we going to solve it? This times this, okay, minus with negative 2000 times negative 2000. Alright, so further solve this, okay, I'm going to multiply now. Multiply, do cross multiplication. So for here, you'll get this times this minus with negative 2000 times negative 2000, right? So you get negative 2000 squared equals to 0. Okay, now, so further solve this, okay, expand these two brackets here. So you'll get 800 omega to the power of 4 minus 4000 omega squared minus 120,000 omega squared plus 6 million. Okay, minus with 4000. There's not enough space over here, so I'm going to do it on the second row. Minus 4 million equals 0. So further solve this. Once you expand everything equals to 0. So solve this, simplify this. So you'll get 800 omega to the power of 4 minus 160,000 omega to the power of 2 plus with 2 million. As you can see over here, there's too many zeros. So I don't want to complicate you guys with these numbers. So simplify this so you can get it to be, I divide everything with 100. So in the end, I'll get 8 omega to the power of 4 minus 1600 omega square plus with 20,000. Okay, now as you can see, we can't solve it yet because this is in terms the power, the biggest power is to the power of 4. So in order for us to solve this, we can solve this. Okay, I've already taught you on this how to solve an equation with the power of 4 before. You change it into quadratic equation. So 8 omega to the power of 4 also equals to omega squared square, right? Equals to 0. So now this is basically, you'll be solving these quadratic equations in terms of omega square. So if you get the answer, if you calculate using your calculator, A equals to 8, B equals to negative 1600, and C equals to 20,000, you get your X and your Y, right? That is actually your omega 1 and omega 2. But remember, we are solving this in terms of omega square now. So if you get your answer XY, which is omega 1 and omega 2, it is actually omega 1 square and omega 2 square. You get your answer in terms of omega square. Alright, so omega 1 you'll get from your calculator to be 13.3975, and omega 2 square you'll get it to be 186.60225. And then you want the omega, right? The question asks you to find the natural frequencies. Got S over there, so meaning omega 1 and omega 2. Solve for omega 1. you get 3.6603 radian per second, and omega 2 to be 13.6603 radian per second. These are your answers for omega 1 and omega 2. Alright. Okay. Now we've already solved for omegas, okay, for the natural frequencies. Now I'm going to teach you how to find the mode shapes. Okay, so my method of finding the mode shapes is, okay, to make life easier, right? I don't want to complicate stuff, okay? So using your frequency equation just now, this is what we get, right? From the last, our simplified frequency equation, sorry. So frequency equation, just now this is the simplified version before we solve it using the determinant over here, right? So use the simplified frequency equation just now, and as you can see here, this is our simplified frequency equation, right? Okay, there's two ways of doing this. Either you use the left side or you use the right side. Okay, you'll get the same answer, but I'm going to show you how am I going to do that. Let's say I'm taking the left side now. All right, I'm taking the left side. So I just put a fraction. I just make it into a fraction. All right, and I change one sign. Either I change the sign for the denominator or I change the sign for the numerator. But it is, since we can change either one of the sign only, so might as well just change it. Just change the side with a simple number. So I'll change negative 2000 into positive 2000. Okay, you can also change it into positive 20 omega squared negative 3000. Okay, over negative 2000. All right, like this. All right, but complicated, so straight away just change one number. Okay, there's always gonna be for mode shapes, okay, either it's a because mode shapes is a fraction, right? So it's always gonna be one side, either the denominator or the numerator, with a single number. So just change that. All right, easier. So negative 20 omega squared plus 3000 over positive 2000. I change the sign for 2000 now. So equals to, okay, the first mode shape, all right, use omega 1, and the second mode shape uses omega 2. So if you use this, just put it as omega 1. All right, now that is how I get for the first mode shape. So let's say I'm gonna find the second mode shape. Just copy back. All right, just copy it back, and I just change omega 1 into omega 2. All right, that's how you find your mode shapes, basically, from your frequency equation. All right, so now just substitute your omega 1 and omega 2 that we've already get just now from the previous slide. Substitute your omega 1 just now is 3.6603 squared plus 3000 over 2000. So you'll get your first mode shape to be 1.366. All right, same goes here for the second mode shapes. Negative 20 times omega 2. Okay, omega 2 squared. So omega 2 just now is 13.6603 squared plus 3000 over 2000. So over here, you'll get it to be negative 0.336. All right, and that's how you get your mode shapes. Very direct. Also, okay, you need to know that you can also use the right side. Okay, let's say now, this is the same natural frequency, right? Frequency equation just now, right? The same one. All right. So, or you can use the right side. Okay, so I'm gonna use this now, 2000 over negative 40. Okay, just see. Like just now, just change one sign, either the denominator or the numerator. I'm gonna change the sign for 2000. So negative 2000 becomes positive 2000 over negative 40 omega square plus 2000. For the first mode shape, it is omega 1 square. And for the second mode shape, it will be omega 2 square. Alright, so now substitute the values for omega 1 and omega 2. Alright, your omega 1 just now is 3.6603 square plus 2000. So you get your answer 1.366. So substitute omega 2 for mode shape, for the second mode shape. Omega 2 is 13.6603 squared plus 2000. So you'll get your answer to be negative 0.366. Alright, as you can see over here, either you use the left side of your frequency equation or the right side of your frequency equation, you'll get the same answer. Alright, you'll get the same answer. So remember, during the exam, during your test, just use one. Alright, you don't have to find like what I did, as what you can see on your screen now. You don't have to do both ways. Okay, just do one. Okay, just do one way. Alright. Okay, that is how you do for chapter 5 in order to find your omega, your natural frequencies, and also your mode shapes. Alright, thank you.